All right, let's jump right in. Welcome to today's Explainer, where we're tackling what might just be one of the most important and honestly most misunderstood tech presentations of the entire year. So, NVIDIA CEO Jensen Huang recently spent nearly 2 hours up on stage at Computex 2026. But if you tuned in expecting a standard product catalog or just a list of the latest graphics cards, you probably walked away a little confused, because it really wasn't a product launch at all. It was a massive, overarching vision statement. Today, we are going to decode that keynote together and uncover the actual strategy driving all that hardware. Here is our quick roadmap for today. We're covering 1. The Computex 2026 vision. 2. The era of physical AI. 3. Rubin, the infrastructure engine. 4. Alpamayo, reasoning and actuation. 5. Full-stack deployment with Mercedes-Benz. And finally, 6. The developer playbook.
Starting right off with Section 1. The Computex 2026 vision, a roadmap, not a catalog.
So, what was the actual point of that 2-hour marathon? It is so easy to just get lost in the hype of teraflops and bandwidth numbers, right? But NVIDIA is sending a very deliberate signal to its developers and partners. They're laying out exactly where computing is headed and making a very strong case for why they need to sit at the absolute center of it all. To really grasp this, we have to look past the shiny new hardware and see the strategic through line they've been carefully building up since CES earlier this year.
Which brings us to Section 2, the era of physical AI. Perceive, reason, act.
And here is that through line, physical AI. Look, we've spent the last few years totally amazed by AI that can, write essays or generate incredible images from a prompt. But physical AI? That's a fundamental shift. We're talking about systems that can actively perceive their environment, reason about what's actually happening around them, and then take physical action in the real world. This is the absolute baseline you need to keep in mind for everything NVIDIA is doing right now.
And I think this quote brilliantly captures the scale of their ambition. Jensen Huang said, "The ChatGPT moment for physical AI is here, when machines begin to understand, reason, and act in the real world." Think about how much ChatGPT completely changed text generation. NVIDIA believes we're at that exact same tipping point right now for robotics, autonomous vehicles, and industrial automation. They absolutely do not see this as some fun lab experiment. They see it as an imminent, massive shift across the entire industry.
Moving to Section 3, Rubin, the infrastructure engine, co-designing for the future.
Now, the hardware architecture here reveals NVIDIA's true philosophy. Because to pull off physical AI, you need an entirely new breed of supercomputer. Enter the Rubin platform. Notice how NVIDIA isn't just throwing a slightly better GPU at the problem. Instead, they're utilizing extreme co-design across 6 completely different chips, from the Vera CPU and Rubin GPU, all the way down to the networking with Spectrum 6, Bluefield 4, Connect X9, and the NVLink 6 switch. These are heavily engineered to work seamlessly as one unified, incredible AI supercomputer. But here's the crucial point. Why does all this extreme co-design even matter? Look at this number right here, 10x. The Rubin platform is aiming to deliver up to a 10x reduction in inference token cost compared to their previous Blackwell platform. And for developers, that is literally everything, as the whole industry shifts from just training models in a lab to actually running these massive physical AI models out in production environments, doing the actual inference. Cost efficiency is the absolute name of the game.
Actually, scratch that, it's not just about inference. Rubin also requires 4x fewer GPUs to train massive mixture of experts, or MOE models. And if you aren't familiar, MOE models are basically these AI systems made up of highly specialized submodels working together to solve problems. Dropping the hardware requirement by a factor of 4 dramatically lowers the barrier to entry and really accelerates the timeline for AI labs trying to build the next generation of reasoning models.
Let's actually walk through how this computational engine builds on itself. Step 1. You've got the Vera CPU, packing 88 custom Olympus cores designed specifically for power-efficient agentic reasoning. Step 2. The Rubin GPU itself, which features a 3rd-generation transformer engine. And then Step 3, to tie the whole shebang together, the NVLink 6 switch delivers a mind-bending 260 terabits per second of rack bandwidth. Guys, that is literally more bandwidth than the entire internet, moving data seamlessly for these massive workloads. It is just an absolute infrastructure engine.
Section 4. Alpamayo, reasoning and actuation, software for the long tail. All right, so we've seen the hardware. Now let's look at the software models actually running on it. For years, traditional autonomous vehicle, or AV, architectures kind of separated the perception modules from the planning modules.
And the problem with that? They completely hit a wall when they encountered weird, rare edge cases, what the industry calls the long tail. Well, NVIDIA's Alpamayo changes this completely. It uses vision language action, or VLA models, to perform end-to-end chain-of-thought reasoning. So it brings this human-like, step-by-step thinking to conquer those super unpredictable real-world scenarios.
Specifically, they announced Alpamayo 1. It's the industry's first open reasoning VLA model, built for the AV research community, and it packs a massive 10 billion parameters. What's truly fascinating here is that it takes video input and actually generates trajectories alongside its reasoning traces. It literally shows you its homework, the logic behind its driving decisions. And that is absolutely critical if we want to build trust and explainability in physical AI.
And get this, they aren't keeping it locked away in some corporate vault. NVIDIA is releasing a complete open ecosystem. You've got the Alpamayo 1 models available right on Hugging Face. You've got AlpaSim, an open-source simulation framework on GitHub for testing. And you have over 1,700 hours of physical AI open datasets, covering incredibly diverse, complex edge cases. They're basically handing researchers the exact tools needed to fast-track safe, reasoning-based autonomy.
Section 5. Full-stack deployment. Mercedes-Benz, bringing it to the real world.
So how does this all translate to actual business? Look no further than the all-new Mercedes-Benz CLA. It features NVIDIA's full-stack Drive AV software. We really need to translate what this PR move actually means. This isn't just Mercedes buying an NVIDIA chip and then writing their own software to run on it. No, this is NVIDIA's first entire stack endeavor in automotive. They are running the full driver assistance pipeline. It completely proves that NVIDIA wants to own the software running the machine, not just sell the silicon inside it.
Let's break down what a true full-stack deployment actually looks like in practice. It's this three-computer cloud-to-car architecture. First, you have massive NVIDIA DGX systems sitting in the data center training the AI on real-world data. Second, you use NVIDIA Omniverse and Cosmos to simulate and validate those features in digital factories and virtual environments. And third, you push all that down to the Drive AGX compute that's actually inside the vehicle, processing reality in real time. It's a closed-loop system entirely powered by NVIDIA.
Section 6. The Developer Playbook. Navigating the taller stack.
Let's bring this all home. What is the developer playbook here? First off, the stack is getting taller. Integration points are shifting way up from the driver level to the platform level. Second, models like Alpamayo are abstracting that entire sensor-to-control pipeline. Third, robotics and embodied AI, they are not side bets anymore. They are primary verticals for NVIDIA right alongside automotive. And finally, we can't forget that active competition totally exists. AMD, Qualcomm, and Intel are all vying for this exact same space. You absolutely have to evaluate your infrastructure choices against a very contested market.
Now, if you're planning out your infrastructure roadmap, here is the practical timeline you need to care about. Back in December 2025, NVIDIA's tech licensing with Grok signaled a massive focus on real-time inference efficiency. By the second half of 2026, the Rubin platform becomes available to partners, so that is when the next-gen hardware drops. And looking ahead, NVIDIA's own robotaxi testing with partners is slated for 2027. That tells you exactly when they expect this physical AI to really hit the streets at scale.
Which leaves us with this final crucial thought. NVIDIA is making a very loud, very clear case that they want to own the computing stack from the silicon all the way up to physical actuation in the real world. So the question you really have to ask yourself is, as we dive headfirst into the era of physical AI, how must your own infrastructure and development roadmap adapt? Are you going to build on top of their full stack or piece together your own? Thank you so much for joining me for this explainer. I hope it gave you a much clearer picture of the strategy driving the AI industry forward right now.